1,280. That is the entire breeding population of everything that would ever become human. Not one region, not one tribe, everything. Fewer people than fit inside a single large secondary school. And they did not spend one bad century down there. They stayed that small for 117,000 years. At the generation length the researchers used, that is close to 5,000 generations in a row. 5,000 times a population that small-handed itself forward to the next one and did not fail. That is the part the number never explains on its own. A population that small is supposed to die. Not in 100,000 years, in a few thousand. So how did they hold? The number comes from a 2023 study led by a group of geneticists in Shanghai and Texas. They built a new statistical tool and pointed it at the genomes of 3,154 living people. The idea is that a population leaves a shape in its own DNA the way a river leaves a shape in a valley. You don't need to have seen the flood. If you know how water carves rock, you can read the flood out of the canyon walls tens of thousands of years later. What they read out of the walls was a collapse. Somewhere between 930,000 and 813,000 years ago, the ancestral population dropped by about 99% and stayed down. Their estimate is that roughly 66% of the genetic variation our species could have had was deleted in that window, never came back, and here is what made people take it seriously. The geneticists were not looking for this. It fell out of the model. Then somebody checked the fossil record for the same window and found it strangely conspicuously thin on 2 continents at once. Now the first thing that actually answers the question. Almost every retelling of this study reports 1,280 as a body count. It isn't one. The phrase the researchers used is breeding individuals, and in population genetics that is a technical term called effective population size. It does not measure how many people were alive. It measures how much genetic shuffling was going on. Those are very different numbers, and the gap between them is enormous. If a handful of men father most of the children, effective size drops. If half the group dies before reproducing, it drops. If the population booms in good centuries and crashes in bad ones, it drops toward the worst years, not the average ones. In genetic terms, your loud uncle with 6 kids counts for more than 4 quiet neighbors who had none. In 1995, the geneticist Richard Frankham reviewed the numbers across wild animal populations and found that effective size averages around 10% of the real headcount. For large-bodied mammals, it often runs nearer 30%. Run 1,280 through that range, and you get somewhere between roughly 4,000 and 13,000 actual living people. Still almost nothing, but it is a completely different survival problem. 4,000 people is not a village. It is a species thinly smeared across a continent. Here is the second thing, and it is the one that flips the whole story. Conservation biologists have spent 40 years arguing about exactly where the survival line sits for a small population. The classic version came from In Franklin and Michael Sewell in 1980, and it is still taught. An effective size of about 50 to avoid inbreeding collapse in the short term. About 500 to keep enough genetic variation to keep adapting indefinitely. In 2014, Richard Frankham and his colleagues argued those numbers were too generous and should be doubled. 100 and 1,000. Look at 1,280 again. It clears the old threshold. It clears the revised, stricter one too. Barely, but it clears it. The number that gets reported as humanity almost went extinct is, by the standard conservation biologists actually use in the field today, a population sitting just on the viable side of the line, not a doomed population. A population parked at the absolute minimum and held there. For 5,000 generations, they paid for it. That 2/3 loss of genetic variation never healed. It is the reason 2 chimpanzees from neighboring forests can carry more genetic difference between them than 2 humans from opposite sides of the planet. You are more closely related to a stranger in another hemisphere than a chimp is to the chimp in the next valley over. And the third answer is the one that does most of the work. A single band of 1,000 people in one valley is fragile in an obvious way. One drought that lands on that valley, one disease that gets into that camp, and the story ends. Scattered bands are a completely different machine. When one band failed, the space it left got refilled from a neighboring band. Local extinction happened constantly and meant nothing. And the thing that keeps a small population from strangling itself with inbreeding was never its size. It was the traffic between groups, people moving to find partners. which is a boring sentence for something that was probably the single most important survival behavior our ancestors had. We know they were spread out because we have their footprints. On a beach at Happisburgh, on the Norfolk coast of England, a storm in May 2013 stripped the sand off a layer of ancient estuary mud. Underneath were about 150 hollows. Around 50 were clear enough to measure. They were footprints, at least 5 people walking south along a river mouth, somewhere between 850,000 and 950,000 years ago, adults and children. Estimated heights from 93 centimeters to 1.73 meters. The team photographed them from every angle for 2 weeks. Then the tide took them. Sit with the date that is inside the window. At the deepest point of the deepest dip our lineage has ever recorded, somebody was at the northern edge of the inhabited world, in a place with real winters, thousands of kilometers from Africa, and they had brought a child to the beach. Those particular people belonged to a species called Homo antecessor, and where exactly it sits on our family tree is still argued about. But whoever they were not huddled in one African valley waiting to die. Which brings us to the argument that is going on right now, and that almost nobody covering this story mentions. In 2024 and 2025, 2 separate teams tried to reproduce the result and could not. A group at Berkeley led by Deng, Rasmus Nielsen, and Nielsen Song ran a test that is hard to argue with. They simulated a population that only declined mildly, no crash at all, then fed it to the same tool. The tool reported a severe bottleneck that they knew for a fact was not there. Their conclusion was that the crash is probably a statistical artifact. Trevor Cousins and Aaron Durvasula, working independently, found that a model with no bottleneck in it fits the real genetic data better than the model with one. And there is a simple logical problem sitting underneath all of it. The signal shows up clearly in African genomes and not in everyone else's. But African and non-African populations only separated within roughly the last 100,000 years. Anything that happened 900,000 years ago should be written into every human alive. There is also an older idea from Armando Mazet and colleagues back in 2016 that produces exactly the same genetic fingerprint from a population that never shrank at all, one that simply broke into pieces and stopped trading people between them. In 2026, the original team fired back, reran everything, and said the signal holds up in both African and non-African data after all. Nobody has won yet. But notice something about the 2 competing stories. If the crash was real, our ancestors survived it because 1,280 was just barely enough, and because being scattered meant no single catastrophe could reach all of them at once. If the crash was not real, then the reason our DNA looks like a near extinction is that the population had fractured into groups so isolated that genetically it behaves like a tiny one, crash or fracture. Both answers are the same word wearing different clothes, separation. The condition that looks like the weakest moment in human history is the same condition that made it survivable. We don't know their names. We know the length of their feet, because 5 of them crossed wet mud on a cold estuary, and the tide came in slowly enough that day to keep the shape. The smallest print belonged to someone about 93 centimeters tall. The argument in genetics is only about how close the ending came. Nobody is arguing that something enormous happened. So, crash or fracture, which one would you put money on?